In this video, we're going to look at solving a system of equations by using the method of substitution. And as we work our way into this video, we're going to start off with problems that require the least amount of work to some that are a little bit more involved. Now, the process to solving by substitution is simple. What you want to first do is you want to isolate one of the variable equations to be either x equals or y equals. The second thing you're going to do is you're going to substitute that equation into the other equation, and then after you do that, you're going to wind up solving and getting a value for either x or y, whatever variable is left, and then once you do, you're going to plug it back in. And so let's look here at this first problem we're given. So the first problem we're given, we have y is equal to 2x minus 14 and y is equal to negative 5x. Now technically, both of these equations are written explicitly, so they're both written as y equals. So what we can do is, since one y is equal to 2x minus 14 and another y is equal to negative 5x, is we can set those equal to one another. So I'll say 2x minus 14 is equal to negative 5 times x. Now from here we would solve it just like we would any other algebra equation. We're going to pick and get our x's on the same side. So I'm just going to move the 2x to go over here with the 5x. I got to subtract it from both sides. We get negative 14 is equal to negative 7x. And then we would divide by negative 7 on both sides. And we wind up getting x is equal to positive 2. Now, we know what the x value is. What we do from here is we want to solve for y. So you go find the easiest looking y equation you can find. I'm going to say this one right here. It looks easiest to me. And I'm going to say, take y is equal to negative 5x. And I'm going to put that 2 that we just solved for in where x is. So y would equal negative 5 times 2. And then we're going to finish solving. And we get y is equal to negative 10. So we have the x value and the corresponding y value that will solve this system. Now remember, technically the system is a data point. So you might have to, in some occasions, write it as a coordinate. And if I had to write it as a coordinate, it would be 2 comma negative 10 would be my answer to this system. Let's look at another example here. So in this problem, we have y is equal to negative 2x plus 1. And then our other equation is not written as y equals. It's negative 3x minus 2y is equal to 5. So this problem requires a different approach. So we're already given the fact that y is equal to negative 2x plus 1. So what we have to do here is we're going to actually do the substitution method. So I'm going to start writing this second equation. And so I'm going to write it as, I'm going to say negative 3x minus 2. But now that I get to y, remember, y is the same thing as negative 2x plus 1. Let me change colors. And so where the y is, I'm going to open a parenthesis, because anytime you do substitution, it's a good habit to use substitution inside of parentheses. And so I put the y expression where it belongs. Now I continue writing the rest of the equation. So we have this here. Now our equation is all in terms of the same variable, so we just would solve it like we would any other algebra equation. So we're going to distribute that negative 2. That gives us plus 4x minus 2 is equal to 5. Combine our like terms on the same side, so I could put the negative 3 and the 4x together. That gives me x minus 2 is equal to 5. And move the 2 to the other side by adding, and we get x is equal to 7. So I got an x value of 7 that will be a solution to the system. Now what we're going to do from here is, since we already had an equation written explicitly, so x equals or y equals, in this case it's y equals, I can solve for y simply by writing that expression, but instead of writing the x, I'm going to put in the x value of 7 into there. So instead of negative 2x plus 1, I have negative 2 times 7 plus 1, and then we would evaluate. So it would be negative 14 plus 1. We get y is equal to negative 13. So there is the x and the y value to solve the system. Now remember, the solution to a system graphically, as we saw earlier, is a coordinate that relates those two values together. So there is a coordinate that would solve the system. All right, another example here. So we're looking at the two equations to solve. We have negative x plus 2y is equal to negative 3. And then we have 3y plus 4 is equal to x. Now, My goal is to take one of these equations and to solve the system by substitution is to have one of them as x equals or y equals. We're already given an equation written as x equals here. X is equal to 3y plus 4. So what I'm going to do is I'm going to take that equation, I'm going to put it back into the other expression. So I'm going to start writing the other equation, but as soon as I see x here, I'm going to open a parenthesis and I'm going to input the equation that x represents in purple. So here in purple, x is representing or equal to 3y plus 4. And so I put it inside of my problem inside parentheses, and now we go solve that expression. And so we would distribute that negative. We get negative 3y minus 4 plus 2y is equal to negative 3. And then we would solve this from here. We'd go combine like terms. We'd have negative 1y minus 4 is equal to negative 3. We would move the 4 by adding to the other side. Negative y is equal to positive 1. And then divide both sides by a negative right there. We get the y value of the solution to the system of negative 1. So all we need to do here now is to solve for x. Well, we have an x equation that is written explicitly. So all we need to do is take our y value and we're going to plug it in to that equation that will allow us to solve for x. So we're going to put that negative 1 inside of parentheses where the x is, or excuse me, where the y is in that equation. We're going to evaluate. So it'll be negative 3 plus 4 is equal to x. So positive 1 is equal to x here. Now, to write our answer as a coordinate, representing the intersection of the two curves, it would be at x is equal to 1, y is equal to negative 1. Now I look here at this next problem. We have 6x plus y is equal to 23 and 3x minus 8y is equal to 20. Neither one of these equations are written explicitly, meaning neither one is written as x equals or y equals. So in order to solve by substitution, we have to have one of those two equations written as x equals or y equals. So you go pick the easiest looking problem that you have and the easiest variable to write for x equals or y equals. Well, that variable is going to be that y right here that I highlighted. It's very easy to isolate that variable. All I have to do here is minus the 6x to the other side, and we have an explicitly defined function as y is equal to negative 6x plus 23. So I have that equation there to work with. So now it becomes a problem like what we had before, where I'm going to go into my other equation here in green. I'm going to start writing it 3x minus 8, but where I see the y, I'm going to put in that equation that we have for y in red. So I'm going to put it inside of parentheses. We have negative 6x plus 23 inside of here. And now we're going to solve this equation algebraically. So I would have to distribute that negative 8. So we have 3x that make plus 48x. And then we have negative 8 times 23. So that's going to be 184. And then is equal to 20. Combine our like terms here. We have 51x minus 184 is equal to 20. Add the 184 to the other side. Forgot the 184. We get 51x is equal to, what is that, 204. And then we would divide by 51. And this gives us x is equal to 4. So we have the x value of 4 that's going to represent the solution to that system. To get the corresponding y value, we go back to our explicitly defined function. We'll say y is equal to negative 6, but I'm not going to write x. I'm going to plug in that value that we just got for x of 4 into it. So we're going to put 4 in, and then we're going to go evaluate. So we have y is equal to negative 24 plus 23. And we get the corresponding y value to be negative 1. And so if I was going to write the solution to the system as a coordinate, we would have an x value of 4 with the corresponding y value of negative 1. Okay, and now we have one more problem. So this will be the last possible case we'd have where we're looking, and again, we don't have any of our questions or equations here are going to be very easy to rewrite as x equals or y equals to solve this by substitution. I'm going to have to do division. And so, again, strategically, we're trying to pick the easiest variable to solve for. And I try to avoid fractions. Like, for instance, if I solve this equation here on the right for y equals, I'm going to wind up having to divide 7 by 3 and deal with that fraction. Or if I was going to solve for x, I'd have to divide the 3 by 7 and the 18 by 7. It's just going to get pretty gnarly. So I'm going to see if I can't find a better option. Like if I went to the equation on the left, solve this one for y, I'd have 4 divided by 8 and 4 divided by 8. That's not too bad, but still a fraction. However, if I solve for this x here, I would wind up dividing by -4. So 8 divided by 4 is a whole number. 4 divided by 4 is a whole number. So I'm picking that x to solve for. That's kind of my thought process here. So I'm going to start isolating it. I'm going to start by moving that 8y to the other side. So I got to add that 8y. I have -4x is equal to 8y plus 4. And now we divide by -4. Divide every little piece by -4. And we get x is equal to -2y minus 1. There's our explicitly defined function for x. Now we go into our other equation. We do just like what we did in the other problem. So we start off by writing it, and as soon as we see that x, we're going to open up a parenthesis, and we're going to input that expression that we have for x that only has y's in it, so that way we can solve. So inside of that parenthesis, we'll have -2y minus 1. Now it becomes just a simple algebra problem that only has one variable in it. We're going to distribute and solve. So we get 14y plus 7 minus 3y is equal to 18. And go combine like terms because they're on the same side. 14y minus 3y is 11y plus 7 is equal to 18. Move the 7 to the other side, so I'm a -7 to both sides. 11y is equal to 11. Divide by 11. And we're going to get y is equal to +1. So we have the y value that will solve the system. We just need the x value. So we have the y value that will solve the system. We just need the x value. So I'm going to take my x equation. I'm going to start writing it, but where I see y, I'm going to open a parenthesis, and I'm going to substitute that value that we just got in for y there. So y was 1, so I'm going to put in a 1 there. And then we're going to evaluate. So x is going to equal -2 minus 1. We get x is equal to -3. So we have the x value that will solve the system, the corresponding y value that will solve the system. We're just going to we're going to write them as a data point or a coordinate that where these functions would cross graphically at -3, 1.